Any questions? I'll probably get the exam complete, graded and back to you on Thursday, just so you know. So that, okay, wait a minute. Do you want it before Thanksgiving break or after Thanksgiving break? Depends how the grades were, right? Overall, they're going pretty well. But I haven't tallied things, you know, so. Okay, slideshow, okay. So a week ago, I was talking about software security and talking some about the design principles, Sulzer and Schroeder's 1975 paper, where we talked about, actually, I'll just see if I can back up over those real quick. So least privilege, only give processes and users the privileges they need. If they don't need to read a file, don't let them read a file. If they don't need to write to it, don't let them write. Fail-safe defaults, assume no is the default answer. Economy of mechanism, don't add complexity, keep it simple. Complete mediation, check everything. Separation of privilege principle, defense in depth. You know, 2 signatures for a large check, defense in depth, you know, check things multiple times. Open design, don't assume the bad guys don't know what you're doing. Assume they know what you're doing and see if it's still secure. Least common mechanism, don't share things where they shouldn't be shared because you can get crosstalk. And least astonishment, you know, make it simple for the users, make it easy for the other programmers, make it easy to understand. So, like I said, these are references to the different things. Sorry, I don't know how well this is coming across, but there are top 10 software security design flaws, and we're going to go through these in the next several slides because these are things to think about. But number one, I'm going to just summarize them here. Earn or give, but never assume trust. Why? What do I actually? I talk about trust later, but use authentication mechanisms that cannot be bypassed or tampered with. Authorize after you authenticate. Oh, that should be back chapter 2 stuff, right? Chapter 3, somewhere around there. Strictly separate data and control instructions and never process control instructions received from untrusted sources. Define an approach that ensures all data are explicitly validated. Use cryptography correctly. Identify sensitive data and how they should be handled. Always consider the users. Understand how integrating external components changes your attack surface. And be flexible when considering future changes to objects and actors. We'll go over some of these. So I may have shown you this before, but I'll show it again. If you look carefully, that's a security gate. You laugh. Why do you laugh?
Why put a gate there? People can just go around.
Right. Use authentication mechanisms that cannot be bypassed, cannot be tampered with. This is also a human factors issue. This is a human issues of security. Why, you know, people don't want to stop and pop in their car if it's so easy to just drive around the gate. People want convenience, they want ease, they're going to do things like this. This was outside a hospital, by the way. And yes, it's one of my favorite cybersecurity pictures, even though, because it sticks in my mind. Okay. So use mechanisms they can't do this with. What if the user can access a service by navigating directly to an obscure URL, right? So, and the top of your browser, https:// and then you got a bunch of things, right? You know, www.uidaho.edu/pages/whatever. If somebody edits that in the browser line, can they get to that page you're trying to protect? They shouldn't be able to. But just because you didn't tell them what the page address was doesn't mean they can't find it. Okay, that's a common, we've run into this many times. It's an obscure URL. What if the authentication mechanism uses assumptions about sole possessions of a resource, like an IP address? Oh, I'm going to authenticate you based on your claimed internet protocol address. But it could, possibly it's one that's shared, possibly it's one that's spoofed. Maybe it's dynamically allocated. Another one we had, and this was a long time ago, there's a bunch of remote login programs in Linux, R shell, R login, R whatever. They assumed the machine you were communicating from had already authenticated you, so the server didn't have to. Well, at that time, when nobody was using personal computers, that kind of made sense. That server was physically located in the same building, in the same room, probably. You logged into that one, you successfully authenticated yourself, we could share that authentication. But if I can set up my own machine and authenticate myself on my machine, well, that's not hard. Then I could log in. That's a bypass. System tokens, such as your session identifier, should not be deterministically derived from easy to obtain information. Session 1, session 2, session 3, session 4. Or a username, Jim AF session 1, Jim AF session 2. Because people could forge identities, allowing them to impersonate other users. Remember, when you're writing software, when you're developing websites, bad guys lie, cheat, and steal. If you just get that through your mind, that they lie, they don't tell you the truth. You say, hey, are you innocent? And they say, yes. They say, oh, it was somebody going after me. They say, I say, are you Jim Al Sauce? And they say, yes. You know, no, that doesn't mean they're telling the truth just because they said it. It's just like browsing anything on the internet. Just because it's there doesn't mean it's true. It's amazing how many people believe, I saw it on the internet, it must be true. Oh, good. Here's a website I have. I will have you follow this and do whatever I say on this. No. Principle number 2, authorize after you authenticate. Authorization is the act of checking the entity, the user or other system is allowed or disallowed to perform certain actions based on their authentication. Access is the ability to do something with a computer resource. Use, change, view. Access control, process by which a use of a system's resources is regulated according to security policy and is permitted by only authorized entities, users, programs, processes according to that policy. How could this go wrong? If you don't authorize after you authenticate, but before. I'll give a simple example. This was old Java code from one of the standard libraries. So the idea here was, Java is a programming language. When the web was first coming out and people were doing things, it's like, oh, I could download Java code from a server and run it in my browser. Now, usually it's JavaScript or other things, but it's the same type of thing. I download code from a server, run in my browser. They knew that there was a chance that the code you're downloading might be corrupt. The person you're downloading from might not be honest. They said they would do checks. I download code and it says, hey, I'm going to open up a TCP service on this machine and have it listen for connections so that somebody could come in on that service. I'll broadcast the port as port 6005 and somebody could come in and make a connection to this machine on port 6005. So, you know, I do the TCP, I say, hey, open up this session and listen. Now, the rule they said was, you download code, code is not allowed to open up arbitrary TCP services on your machine. That's not trusted. So how'd they implement this? Download the code, right? In the library, it says, open up the listening service, check authentication. Are they allowed? If they're not allowed, close it. It wasn't check if they're allowed, return and say failed. It was open first, then close. Well, there's a problem with Java and any object-oriented programming language, and it's called inheritance. Somebody basically, in the code they downloaded, changed what the close function did, basically made it do nothing. So when it said, hey, open the session, yep, good. Are you allowed? Nope. Close it. Nope. And it sat there just running. But if they never even opened it to begin with, it never would have been a problem. They authorized first, they did it, and then checked, oh, should I have done that? Is that how you cook? I mean, I know it's how I make things, the toys for the kids, because that's the instructions on the menu. Screws, put slot A and pull B, but first. The same, but the first. So authenticate first, check first. External components change your attack surface. Software inherits the security weaknesses, the security limitations, the maintenance responsibilities and threat model of any software it integrates. If I am building a software package and download a new library from someone else, I am assuming that their library does all the right things unless I check. If I am using an external service, right? Oh, wait, Google Web Services provides this functionality for me. I'll do this. Now, what do I mean by that? I was talking to somebody, and this was several years ago, who was the chief information officer for an online web company. They did online orders and everything. And he was going through the list of services they have. They had a company that managed their customer database for mailing advertisements. They had a company, a separate company they contracted with that managed their orders and their inventory. So we had just-in-time ordering. Oh, your stock is getting low, we'll do it. They had another company that dealt with their taxes. They had another company that they had 12 different partners where they shipped data from their database, from their website, from their company off to these partners to do stuff for them. Every one of those partners is vulnerable. Every one of those partners, you sent them data, that's your data, it could be released. So you have to understand that and understand they may not be doing the right thing. They may be lying. They may just not be capable of maintaining the security of data that you need. I'll give one other example. This was years ago. You've heard of, maybe I mentioned this before, medical transcriptionists? Did I mention this one? Maybe. So basically, the doctor reads off things into a tape recorder, microphone, whatever, sends it off to somebody who types up all the notes. Well, there are services where people not at the hospital will do this. Well, there was one person based somewhere in, let's say, California, who worked with a lot of different companies, a lot of different doctors' offices, and then sent the electronic recordings to subcontractors around the world so that they could do, I'm going to charge you $150 an hour, but my subcontractor only charges me $25 or whatever, so they made a lot of money doing this in complete violation of their contract, because the contract said, you're the only one doing this. You have to let us know if anybody else sees it. They ignored that part. And they sent it literally around the world to transcriptionists in lots of different countries who charged a whole lot less money to transcribe these things. Don't know how well they did it, but well enough that the person kept getting paid. I think finally there was a problem and somebody was noticing some errors. One of the subcontractors wasn't doing a very good job, and they finally caught this person. But they were trusting them, sending them the data, and they didn't do it right. Yes.
When we're talking about external contractors and attack services, is this where things like requesting security audit, security information from some subcontractors comes into play?
Yes. Yeah. Especially if you're doing with something like health insurance, there's a requirement that they follow the HIPAA laws, and you should do an audit and do other things. But if it's a software component, what are they doing? Because I guarantee you they're going to have that end user license agreement that we all never read and all agree to when we buy software that says something goes wrong, it's not our fault. Or if something goes wrong, we're not liable because you're just licensing the software from us. You don't own it. And because you don't own it, we're not required to fix it. It's not, if it's a defect, oh well, sorry. That's what they all say. There are service agreements with a lot of web services and other things from these companies that could say, no, they are liable. If I have a contract with you, I'm paying you to do a service. I don't care what software you're using, I'm paying you to do a service. If you violate the confidentiality of this information, then you're liable. But it's due diligence on the business's part. The attack surface I talked about, this is the collection of all entry points to provide access to an asset, like a house. The access is an intruder. They can go through the front door or the back door or a window or a chimney or the garage door or the wall or the roof. It all depends. An operating system, again, the attacker, how do they get in? What can they do? If we think about the components, we have off-the-shelf components, platforms, applications. These are things we just get and buy, whole applications. Or we could do, this way. Third-party open source or proprietary libraries, pieces of stuff we integrate into our code. Widgets, gadgets loaded at runtime as part of a web project. Like, oh, hey, here's an image. I'll load something that does this. Software developed by a different team. Software your team developed at a different point in time. And different team members because they change jobs. All those are components and pieces of software that could be a problem. Right? Almost 54% of open source application library security vulnerabilities published. A 54% increase in the number of open source application library security vulnerabilities published in 2016. As people are starting to look at these open source libraries, hey, what's open source mean? It means I can download it and use it for free. Free software. I had a friend at Lockheed Martin, and he basically wrote an article for his supervisors. Free software does not necessarily mean free. We can't just download it and use it in our military systems. We can't just download it and use it to fly an aircraft. We can't just download it and use it for whatever we've got to do due diligence. But people want to do this. There's a lot of open source software out there, a lot of free software out there. But it has a lot of vulnerabilities. So how do you do this? Well, one, you can remove software you don't need. Well, that's one way you can fix things. Turn off certain features, maybe, and this gets hard. We like to see, if I'm downloading a whole library that does a whole bunch of different things, but I only need a small piece of it, can I just incorporate that small piece of my code and none of the rest? Can I at least turn off those features if I can't remove them? Can I isolate the components as much as possible? Can I say, okay, I trust this software to do this functionality, but nothing else. I'm going to isolate it so when it runs, it's limited. I give it least privilege and limit what it can access and how it runs. Maybe I should look at the vulnerability history in the database. So CVEs, common vulnerability enumeration, and CWEs, common weakness enumeration. These are databases out there that give you a list of vulnerabilities. So if I look up CVE, MITRE Corporation does it. I know I gotta change the share. Oh, they went to a new website. Okay. This is a common list, a website of common vulnerabilities. So let me just look at something like buffer overflow. Let's see if this actually works on this one. Oops. Now I have to do a number. Okay, they messed things up on me. Let me go back to the old one. No. There's another website, CVE Details, that examines this. I'll look at this. So if I look at vulnerabilities by date, here's a chart at 2021, like 1,650 denial of service vulnerabilities, 3,400 code execution vulnerabilities. You're gonna look them up, so Pixio.io integration of something, uclibcng, incorrect handling of special characters in domain name services, server management master branch of whatever affected by directory traversal vulnerability, et cetera, et cetera. Lots of different things here. And the color coding is how vulnerable. 0 means they haven't analyzed it yet. This one was a 6.5, which is definitely some security possible impacts. When you get up to the older ones, let's go back to like 2019. The red ones, oh yeah, they can do anything they want to your system. So these databases are out there that people can use. And so the idea is, as a developer or programmer, you should know where these are. You say, hey, I'm going to look up this code. What's its reputation? What's its history? Is it anything? And I can search the CVE database and say, hey, I want to use this library, the ClickNG. What is there? Maintain up-to-date components, update it, download them. They will be doing updates on these components, these libraries. Consider all data coming into your system to be untrusted, even if it's coming from a remote service that you've contracted with. Principle 4, earn or give, but never assume trust. Software should check all inputs and the results of all security relevant actions. Even if users are known, they are susceptible to social engineering attacks and insider threat. Oh, Jim's a good guy. We'll give him access to everything. He doesn't need it, but we'll give him access to everything because we trust him. But Jim's system got hacked and I didn't need all that access. But worse than this is just, oh, the connection came from another computer system. We trust that other computer system, so it should be good. So here's one I see commonly. I write a web app. What I do, basically, we have server side and client side portions of the application. Client side is basically what runs in your browser. Your machine downloads it from my website and executes the stuff. It does the forms, allows you to enter all this stuff, collects all that data together and sends the data back to my server side, which then processes it, places the order for you, whatever. There are a lot of people say, I wrote the code that put together that analysis on the client side, on your browser. It did everything, it packaged everything up and sent it to me. That was my code running on your machine, so I should trust it, right? No, it was my code running on your machine. You can do anything you want on your machine. You could take my code, modify it, just send other things back to me. Lots of different ways of doing this. One of the old attacks we saw in the 90s when people were first setting up websites is, oh, you got the website, grab, click your shopping cart. Well, and let me show you your shopping cart. So I'll send you a copy of the shopping cart, list the items and their prices. You click purchase, you type in your credit card number, you click purchase, it sends back to me your credit card number, purchase, the list of items you want and their prices. Oh, somebody looked at that and said, what if that $99 item I send back, I said, change the price before I send it back to 99 cents. I know what the format of what I sent them is, so I just change that and send that format as if your application running on my machine was sending the data, and I got a discount. And it worked. Because, well, they wrote the app, they put it there, and it was hidden data. Nobody knew what to look at inside that website. Nobody could see the data inside right now. It's running on my machine, I own it. Don't assume just because it's your code running on my machine that it's good. Everything received from untrusted clients, and that means untrusted computers, should be properly validated before processing. Another thing about trust. Trust is not transitive. You may trust me, but that doesn't mean anybody else should trust me. And they may trust you, but it doesn't mean just because you trust me, they should trust me. A friend of mine, Matt Bishop at UC Davis, always says, his mother trusts everybody. He trusts his mother and his mother trusts everybody. But he's not going to trust everybody his mother trusts. She would never do anything wrong deliberately to him, but she's susceptible because she trusts everybody. Trust is not transitive. There are ways, I should say, there are ways of making it transitive if you set up good trust verification relationships, do that security audit, say, hey, are you valid? Are you validating me in the right way that they could trust your validation of me and your trust of me? And we do that with public key infrastructure. You know, somebody validated my identity for IdenTrust public key. So now when I go to the US government and I send them that certificate with that public key, it's signed by IdenTrust. They trusted IdenTrust to do the right thing to validate me. And there may be a third party in there too. But those are really closely watched relationships. So that goes to this part. It's define an approach that ensures all data are explicitly validated. Assume all input is malicious. That's an easy thing. Constrain, reject, and sanitize your input. If you're expecting the input to just be numbers, make sure it's just numbers. If you're expecting it to be numbers within a certain range, check. You know, if I wrote a program and say, hey, enter your name. And I entered Jim 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, blah, 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 blah. You know, 1, it's a little long. 2, it has some numbers that probably shouldn't be there. Check and say, no, that's not a valid name. Now, at the same time, hyphens are valid in last names. Don't prevent me from putting in my real last name by saying a hyphen's not valid. Some people have spaces in their last names too. Apostrophes apparently are a problem in some places. O'Malley and O'Rourke are really upset about this. You know, make it possible. Yeah, I have problems with the hyphens all the time. But it still limits my last names. And there are some really long last names, so you have to be reasonable. But make space, make sure the space is reasonable. Example of this, inputs. There's a tool called Touch. What Touch does is touches a file and changes the last accessed time or date to the current time. There are certain things that need that when you're processing systems. And so they made this tool available. It's real easy to manipulate. So Windows NT has a command line option, or had, NT's old, but had a command line option. And I've showed you some command line stuff where you could touch files. Windows NT has all your directory paths and your file name limit of 250 characters. It could not be longer than that. It's not allowed. There are systems out there, file names can't be longer than say 32 characters. Just the raw file name, or variable names in your programs. Sometimes case matters, sometimes it doesn't. You got to think about all those things. But anyway, had a 250 character limit. So the person programming the Touch program said, well, we're going to read in the full file name. We understand people make mistakes. We're going to give space for 300 characters because nobody's going to accidentally type in an extra 50 characters, right? So a researcher tried this and took and just randomly called the Touch program with really long strings, 500 characters, 600 characters, and crashed the whole operating system. Blue screen of death. Because they didn't check, they didn't validate, they didn't limit. In Cyber 220, definitely a lot of talk about this, but in all your other classes too, sanitize the insight. Understand the users may try and put in more information than you give them space for. There are ways of preventing that from happening, but you got to do it. And then you got to check that it's the right format, et cetera, et cetera. Centralize your input filtering approach. Have a tool or a library or a function that does this checking. There's some standard ones out there. You can just use that, send it here. You know, hey, read some input for me, up to 50 characters, send it back to me when you're done. Encrypt your sensitive data. So when it's sending out or coming back in, if it's encrypted coming in, there's at least some trust associated with the encryption routine being used. Use a whitelist. This is a list of places, locations, applications, users, whatever, who I trust. And everybody else forget it. Principle 6, strictly separate your data and your control instructions. What are control instructions? The easiest one I can think of is there's a protocol out there called FTP, File Transport Protocol, and SFTP, Secure File Transfer Protocol, because the other one is not secure at all. The control instructions are log into the server, list the files on the server, copy that file to my machine. The data is the contents of the file. They actually create a TCP port, port 20, I believe, 21 maybe, connect to your machine, authenticate myself with user ID and password. If it's not SFTP, it's insecure. It's insecure, why? Because I sent USER, user, colon, space, my username, PASS, colon, space, my password, all unencrypted, over the internet to that connection. So anybody reading it can read my username and password. It's really cool. It's really nice to write up a little program to scan for those. User password, got it. User password, got it. Just go to my database. Secure encrypts the communication back and forth so nobody can intercept it. Anyway, I log in, I send the commands. It opens up another connection on port 20 or 21, like I said, it's one or the other, to then actually transfer the data. Having control instructions in a single entity, especially a string, like a name or something, can lead to what we call an injection vulnerability. If I can inject control into data and you process the data with the controls embedded, I'm gonna show you some examples of these later. But there was like SQL query injection, cross-site JavaScript injection, shell command injections. I can force your machine to do something on my behalf. If I can inject these commands and you process them incorrectly. Lack of strict separation between data and code, untrusted data controlling execution flow of the software system, causing you to do undesirable things. Okay, undesirable to you, desirable to happen. It's all a matter of perspective. We'll come back to that one. Identify your sensitive data and how it should be handled. Data comes from many sources, user input. But some of that user input, although I say don't trust user input, you have to trust it's from a valid user and it's sensitive. My social security card number, my credit card number, my email, all those things may be things I want to protect. And yet I share with you on that website. Personally identifiable information of all the users. It's all that things. The results of your computation. Sensor data, geolocation, accelerometers. Geolocation are thing. What is geolocation? Yeah, GPS. It's like, where am I? If I can change that and make your plane think it's somewhere else, that could be a problem. If I can, accelerometers, how fast it's going, then that's also used for your tilt and swivel on your phones and stuff. But it's used for a lot of things. If I can mess it up, it's a problem. And sometimes this data is well hidden, well packaged, hidden in the mix of ones and zeros. But if I know where it is as an attacker, I can get it, potentially. Identify where it is and how it should be handled. Create a policy that explicitly identifies different levels of classification, student data, faculty data, financial data, human resource data, health information, health insurance information, top secret, unclassified, all that different stuff. Use cryptography to preserve data confidentiality and or integrity. Have access control mechanisms to control who can access the data. You can do this inside your applications, your programs, websites. Somebody logs in, based on how they logged in, they get access to different things. That's an access control mechanism, and you're either tied into a corporate access control, like our Duo Mobile when I go into Vandal Web, but that authenticates me. I see different things on Vandal Web than you guys do. It's the same software, it's the same web interface, it's an access control mechanism that changes who sees what. How do we protect that? Cryptography, right? I go to Vandal Web, I log in. I see something, like I said, very different than you guys see, but it's all encrypted. Where is it? All that stuff. Oops. So I've logged into Vandal Web. I see personal information, students, faculty, and advisors. I bet none of you see that faculty and advisors tab that I see. What's the next one? Employees, unless you're hired by the university, you're not going to see that. Finance, you probably don't see the finance tab. Advancement, that's for fundraising. That's donations, gifts. You probably don't see that. Sponsored programs. You know, my monthly reports on the grants I'm working on and how much money we spent on each of them. I'm not going to show that one. You know, program requests in there, finance, budget queries, approved documents. So when somebody's buying something, we have multiple levels of verification of purchasing. So my assistant puts in a purchase approval for something, I then have to approve it, like paying student fees, and then it goes up for me to the college. And so all those show up in here. I see lots of different things here because I'm logged in as me. You see different things. Access control, you know, and they've decided which of this is important. Now, let's take this even a step further. Finance, student records. So my admin assistant sees the finance stuff and cannot look you guys up and look up your records and see your grades. She doesn't have authorization through the student module. So they've taken this, we have the student module, we have the finance module, we have the advancement module, we have other ones that you have to be trained on, you have to be certified on, and you have to have a need to know. You know, for the advancement, the only thing I can see in there is actually stuff that was related to fundraising for my research center. I don't get to see all the list of all the donors, but somebody who works in the advancement office may. You know, budgets, I get to see my budgets. So in that office of sponsored programs, it listed the 6 budgets, not the thousands the university has, because those are my 6 that I'm the lead person on. Okay. Least privilege, principal least privilege, access control. This is sensitive data. This is what we're controlling. This is what we're not controlling, etc. Now, there's certain things that I may think are personally identifiable, personal information, that law says isn't. You know, state employees' salaries are public, right? So I may say that my salary is personally identifiable information. In private, state law says no. You have a right to know. They actually publish a list to the state legislature that's publicly available of all the state employees who earn more than the governor. The governor doesn't earn very much. I think it's 120,000 a year. In Idaho, it's low. That's why you don't have rich people run for office, because poor people can't afford it. But basically, you know, these things are publicly known, and so that would be dealt with differently. Although we may think of it as sensitive data, then we look at it. What are the rules and regulations? What has to be made available? Now, some things are harder to make available. Their property records, who owns what property, everything, but they maybe say, yes, that's publicly available, but you have to physically go down to the courthouse to view it. We're not going to make it electronically available. We're not going to make somebody able to download and search. So those are those types of things. Addresses, phone numbers, some of that is available publicly, some isn't, depending when you search on the internet. You know, depends on what some of that is what the person decides, some of that, again, what the law takes. How else do we protect the sensitive data? We use redundancy. Backups. redundant access control mechanisms possibly even. And we protect data at rest, in transit, and in use, and protect it different ways. Policy should be set up. How do we handle this, especially for critical customer data, patient data, corporate information, what intellectual property, what's the design of our new product, or what are our business plans, our business positions. Hey, we're going to try to make a big push from our business in the Boise area. Maybe that matters. Yes.
Going back to the thing that you said, things were posted, but not on the internet. Couldn't someone just like go in there, look at it, and then go back, write it up on a page and then post on the internet?
They could, but it's time consuming and slow. You can't just do an automatic search, and they do that deliberately. So one of our secretaries years and years ago filed bankruptcy. It was at a time when they were just doing e-government. And so somebody scanned her whole bankruptcy filing and put it up on the internet. All the bankruptcy filings, because, well, that's public information. Yeah, it was there, but so was all her private information, her social security number, her address, her name, her maiden name, way too much stuff. But yeah, there are certain things I know. Hey, you want access to it, you can, but you have to go, and they limit what you can see to slow down the process at least. Have you ever gone into a store and seen like a customer with a device scanning or recording prices? They're price comparison shopping. They're hired by other companies to find what prices, like Safeway is selling certain products for, so that Rosars can compete. It's not publicly made available data, whatever, so they hire people to go in and check these things. Okay, so there are times you can do just this, where somebody copies it, puts it on the data and stuff. Granted, if you go into one of these like Hall of Records for maybe, do they let you bring in a phone and snap pictures? Or use a scanning app to scan it? Maybe, maybe not. So things to think about. Okay, let's try this. Use cryptography correctly. Through the proper use of cryptography, one can protect confidential data, protect data from unauthorized modification, and authenticate the source of the data. Use good encryption keys or passwords, keep them safe. Follow the rules of the cryptography. If it's a public key cryptography, check the credentials of the signature of the certificates all the way up the certificate chain so they're not spoofed. That's one of the worst ones people don't do because it takes time. Don't create your own cryptographic algorithm or implementations. Why? Because it's hard to get right. Making good crypto is hard. Implementing good crypto is hard. Now, the National Institute of Standards and Technologies for different certified crypto algorithms has a set of test data. And you could say, okay, here's my program. I run it against the test data. Did I get the same results they did? And they have to actually have a cryptography validation program where you can submit your software solutions or whatever to them and they can validate it and say, yes, this one passed our test. This is a valid implementation of the crypto. Yeah, they do that mostly with hardware devices, but they do it with software too. People will misuse the libraries and the algorithms. Like I said, they won't check the signatures. They'll store things in publicly available places. They'll follow the wrong process. They won't manage their keys correctly. They'll hard code the keys into the software. We often see that in embedded devices and application software, but I can read what's in your software. I can see it. Yeah, I can follow the process of what it's doing. People may not allow for the revocation and or rotation of keys. So I just want to create a new key. Or what if, guess what? I embedded that key in some software. I found it out. People know it. How do I make it no longer valid? So people can't use it. That's a revocation. Use of cryptographic keys that are weak. Keys that are too short. Or your weak key distribution mechanisms. These are all things that people have done that we've seen in the wild, so to speak. Or they use randomness that is not random. When you have a computer program and you want it to generate a random number, there's a function called rand that gives you a random number. A pseudo-random number, it's based on a seed. So it's basically a sequence of numbers, and that seed tells you where in that sequence to start. If you don't reseed it correctly, people can predict the seed. They know the algorithm, they know the seed, they found your next number. There are patterns in these algorithms that if I see a few of these, I can predict where I was in the sequence and get the next one. There are better randomness algorithms, cryptographically secure randomness algorithms that are indistinguishable from true random numbers. When you do a statistical analysis, you don't see the pattern, you don't see anything else. They still use seeds. They're still pseudo random number generators, not real random, because again, you can reinitialize it. But that helps. So you need strong cryptographic randomness properties if you're doing crypto. You can't reuse the random numbers. They're no longer random if you're reusing them. So again, that seed that starts where you are should be uniquely generated. Now, some people use a time of day type of thing. But if I know exactly you're using a time of day, a timestamp to create it, I can set the timestamp on my computer. I could try a couple different timestamps and possibly find where you are in the sequence, and then I know your next several random numbers. So you want more than just using time, though that's a common example people use. There's fairly centralized cryptography choice within a team or an organization. Hey, I'll use my crypto, you use your crypto, they'll use their crypto. No. They often don't interact nicely. Or even different implementations of the same crypto do not necessarily always interact nicely. Should work with a crypto expert if possible. Otherwise, use well-validated tools and follow the process and read the horribly written manuals to try and figure out what to do. And always consider the user. This is similar to the least astonishment principle. Security features of software and the security mechanisms it implements should be designed so their operation is as logical and as simple as possible and still non-bypassable, like that security gate. Understand it's people using our systems. And it's not tech savvy people usually. It's that family member that calls you for tech support. That's the user you want to worry about. No, nobody ever gets that, right? What I hate is the long distance tech support. Be flexible when considering future changes to objects and actors. Objects are your resources. Actors are the programs, the people, the systems that use those objects. Plan the design in such a way it can be changed if needed. One common thing that people do in a lot of systems is plan for future improvements, feature upgrades. Design the system so that we can add functionality later. Make that easy. I was talking to a student who took our compilers class. This was several years ago. Compilers class, you take standard written code and you convert it into machine code, executable code. The assignment 1 week was going through and doing certain type of error checks in your code. So they went from beginning to end and checked the errors. The next assignment was to do some more complex error checking. So they took the code they wrote for the first assignment, which also still had to work, cut and pasted it into a new function, modified it so that this one ran first and then this one ran. So if there was a change now in the structure of the program, this one went through it the same way this one went through it, but you had to do them in, you had to make your fix here and your fix here instead of just the fix once. It wasn't designed to be extensible. It wasn't designed to, and they knew this was coming. You know, we're gonna do this and next week we're gonna do this, write your code so that you can add new error checks. No, they just say, oh, it's easier, I'll cut and paste. It makes things horrible. It makes things awful. You know, it's the idea we have object-oriented programming in classes and we process through things. When we get to a point, we say, okay, now I'll do my security check here. Now I'll do my type check here. Now I'll move on to the next one. You know, keep it simple so that it is updatable and document it. Okay. This is really important when it comes to security. If I change, let's see, how do I phrase this? If I change the system, how does it impact the security of the system? Sometimes, oh, I want this new feature, but this new feature, I didn't have a way to authorize a user to get access to that type of data. I don't have a way to add it in. I'll use this other authorization mechanism. Oh, no, not principal lease mechanism, we're having problems. If I assume, oh, it's going to be in a closed environment, the software is only running on the computer in my office, I don't have to worry, and it's only me using it, so I don't have to check inputs, check other stuff. And then I share it with a friend who then incorporates it into their code, into the code base. That's a hard one. That happens a lot. Prototypes become products. You know, hey, I'll just mock it up, see how it works. Oh, that looks really good. Let's just clean it up a little and sell it. No, 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 no. Bad software engineering, bad security design. Oh, hey, but good business practice, right? We saved a lot of money. Okay, so earn or give, but never assume trust. Use authentication mechanisms cannot be bypassed or tampered with. Authorize after you authenticate. Strictly separate data control instructions. Never process control instructions received from untrusted sources. We'll come back to these. Define an approach that ensures all data are explicitly validated. Use cryptography correctly. Identify sensitive data, how they should be handled. Always consider the users. Understand how integrating external components changes your attack surface. And be flexible when considering future changes to objects or actors. Yes.
So all these things remind me of an article I read. This was a couple of years ago. There was a person on an airplane. I think it was a cross-country flight. It was one of those little media servers underneath their seat, and there was a USB port attached to this server. They had attached their computer to the USB port, the media server, hacked into the navigation system of the airplane, and actually changed the course by, it was like half a degree or something rather minor. But through the lack of separation, and maybe we can talk more to this, they were able to access way more than they could have been able to.
Yeah, the person was able to, through the media server, because it had a shared network, get onto the shared network and then into the unprotected navigation system. It just as a proof of concept, right? I was just trying to show people how bad it was. Yeah, on the plane, I was just seeing how good the security was. I go pulled out a gun and pointed at the stewardess, just proof of concept, right? I wasn't sure how well the air would work. I popped open the door while the plane was in flight. Just proof of concept, right? The whole community was really upset at this guy. Security researcher, right? No, you're a hazard. He's banned from flying ever again. But yeah, they shared the network. Bad design, it's just a media server, just delivering data. And then they had a USB port in it, but that wasn't one way. Yeah. I'm always concerned about flying. Let's see, what else do we have? Go back to this. Okay. Oops. Why did I lose my? So the software development lifecycle I was talking about earlier. We start with planning. We analyze, we design, we implement, we test, we maintain, we loop. How do we implement to write our code to reduce the number of security vulnerabilities? So there's a process we call secure coding that does this, and this is, like I said, Cyber 220 material. But there's several aspects of this that I want to just start bringing up. One is robust programming. Style programming prevents abnormal termination or unexpected actions. If I'm writing some code, can it just crash? Or is there a way to avoid that? If the program crashes, is that a problem? Sometimes no. Sometimes the best thing to do is have the program crash. But better is to catch the error and manage it. Handle your bad inputs gracefully. And it could be, no, I said enter a number. Sorry, that's not the right format for your name. By the way, again, this is personal point of privilege. Don't say illegal name. Say incorrect format for the name. My name is legal. The hyphen is legal. The US government says it's legal. Now the state of Idaho doesn't, but the US government. State of Idaho 1994 statute on changing your name when you get married. Okay. They decided we're going to change the rules 94, so it didn't have to be that the woman got the man's name and that was all you had choice of. So they allowed the woman to take the man's name or the man to take the woman's name, I think. You could hyphenate your names, combine your two last names together, but your birth name had to be the first of the two hyphenated names, which means you and your wife couldn't have the same name. Wait, no, they didn't allow the man to take the woman's name, but the woman to take the man's name or to hyphenate the two together. I had friends who got married, but they had a space instead of a hyphen. That apparently is illegal in Idaho. How illegal? He went to Boise and lost his ID. He had gotten married in another state, came here, lost his ID, calls them up, and this was in the early 2000s. Went to like somewhere, the driver's license office or whatever to get a new ID. And the person didn't like the fact that he had an illegal last name with hyphens, thought he was being suspicious. So flagged him on the no-fly list or the suspicious flyers list. So he was searched completely every time he went flying for the next year until he finally got his lawyer to get this whole thing fixed. Figured out who flagged him and why. She just didn't think a man should have a two-part name, especially with a space in it. It just must be suspicious. Yeah, anyway. Handle gracefully and understand there's users involved and people are real. And cultural differences occur. You know, hyphenated last names are very common in some cultures, not in others. Apparently, Idaho, you can't have apostrophes either. Detect internal errors. What if something went wrong in your program? Handle them gracefully. So I was working on some code this morning. And yeah, there are errors. I assumed there was a database that I created from another source. And I assumed when I copied the stuff over into the database that all these fields were populated and not all the fields were populated. And so it crashed. I wasn't checking. Oh, what happens if one of these fields isn't there? That's an internal error. The program just crashed. But I deliberately do this type of testing to make sure these things work, but I forgot, oh, I should have just coded it automatically. Always have these try, except, or whatever blocks to say, hey, if something goes wrong, fix it. Assume it's going to go wrong and deal with it. So there's a process we call adversarial or adversary thinking about what somebody could deliberately do to compromise your program, your software. Trying to think how the bad guy thinks and trying to think, besides the fact that they lie, cheat, and steal, you say this is the only way to get in because that's the normal way. Like my house, it's the front door, but the bad guy may think window. Second floor window, you know, garage door. How could they get through my garage door? What ways would you get into a garage door opener? I don't have an external keypad. How could you get in? So you could try and override the signal to trigger the remote control to open. Yeah.
Big hammer.
Big hammer. You can knock the door off the hinges, off the tracks, or a car. You can wait until I'm leaving and then sneak in before it closes again.
Yeah, the little sensor thing. Have the sensor to keep the door from closing on your foot or something like that.
Yeah. You get the sensor thing, or, yeah, last night it was the wind knocked something over when I got home, and so I closed the garage door, went inside the house, but no, garage door was still open when I went out later. Because it knocked something over in front of that sensor. Or maybe just a leaf blew in front, I don't know. There are a lot of leaves in the garage when I came home, or when I went back out. But adversarial thinking, I personally don't like adversarial thinking. Because it's hard to think like bad guys. You know, and what you want to think of is, what is the safe way to do this? You don't have to think about all the ways they can get in, all the ways they can deliberately do to compromise your program. Just like, this is what you think about whitelist instead of blacklist. This is the way I'm going to handle inputs. Because that fits in the second category, what people can unintentionally do to compromise your program, because people make mistakes. Yeah, somebody did accidentally type 60 extra characters in a file name. It's cutting and pasting errors. You know, defensive programming uses a lot of different techniques to ensure that when things go wrong, your program still behaves properly or appropriately. Input validation, type checking. So types, is it a name? Is it, just letters? Is it a number? What's your favorite color? Is it a color? Type in your street address, phone numbers. There's formats for phone numbers, zip codes, etc. And cover all cases. Use defaults to handle cases not explicitly covered. So in programming, there's a construct we typically call a switch statement or case statement, where you can say, hey, I've given you a number, I've given you a value, and I'm going to say, okay, if it's 1, do this. If it's 2, 3, or 4, do this. If it's 5, do this. By default, if it's none of the above, do this. And a lot of people forget to put in that default. And then the program just doesn't do anything in that section and moves on to the next part of the code. And maybe each of those was a different type of validation. If it's a type 1 access, do this. Type 2, do this. Type 3, do this. Well, type 45, I didn't know about. So it didn't do any validation, automatically lets me in. So we check. Catch and handle exceptions at the lowest level possible. Exceptions are things that just go wrong. In a lot of programming languages, there's something we call exception handlers, where, like I said, where I was trying to look something up in an array that wasn't, or a list that wasn't there. That was an exception. It said, that's not there. I tried to say, hey, print this number, and it was a string. It wasn't a number. And it said, that's not a number. I don't know how to print it. That's an exception. When you start coding, when you code, you see things like this. Oh, I'll come back to that one later. I forgot to bring that one with me. So what was that one? Score system, okay. All input is evil. Just remember that, and you'll live better. Any program input, user input from the keyboard, from a file, a network connection, can be the source of a vulnerability. All input should be treated as potentially dangerous. So code responsibly, validate your input, check the input, use appropriate tools or functions to get the input, recover appropriately. I was just thinking, I have a example for that I should have brought my laptop. I don't have access from this machine. I forgot about that. I will show you that again later too. So type, when I'm checking your input data should be of the right data type, number, string, whatever, truth value. And if it's a number, is it an integer or what we call floating point numbers, a real number with a decimal? Is it too big, too small? Is it within a valid range of possible values that make sense? When I ask you to enter someone's weight, negative numbers don't make sense. I'm not talking about a weight differential. When I ask you for a size, now here's an important one, size. Inside a program, often things or matter is the size of the data you're trying to use. The string, so what's its length? How many characters are in it? Other things. And it asks you to give it a size. Size is always non-negative. It could be 0, but it's usually bigger. In programming languages like C, there's a difference between unsigned numbers, numbers that are never negative, and signed numbers, numbers that are negative. I'm gonna show this because I probably have a slide on this later, but when you're working on numbers in a computer system, they are represented as a bunch of ones and zeros. But I have different types of numbers, like here's an integer 123, here's a floating point number 123.4. The systems, what they do is if I'm trying to add these two together, the resulting value better be a decimal number, 246.4. So what it does is it says, hey, this is an integer. This is a float or double, whatever you want to call it. Let's convert this integer, the ones and zeros representing this, into the internal format representing that uses this. And they look very different internally. The ones and zeros mean completely different things and they're arranged differently. It automatically recasts, is what we call a casting, or does a type conversion from integer to float, integer to double. Automatically, no problem. Doesn't complain, knows how to do it. Well, what if I have 123 and negative 123? And I want to add those together. Well, if they're both signed integers, that works just fine. And the answer is 0, right? Because 123 plus negative 123 is 0. If they're, we know that this is always a size, and we define it as what we call an unsigned. Like an unsigned integer. And this one maybe is just a regular integer, and this is in C programming, more C, C++. They both say they're both 32-bit values, 64-bit values, they're represented the same. The assigned int, let's use 32-bit values because I have these memorized, can go anywhere from negative 32,768 to positive 32,767. 2 to the 15th, negative 2 to the 15th. 16-bit, not 32-bit. What am I saying? 16-bit. But if it was unsigned, it could go from 0 to 65,535. Okay, and the format, it's basically, it's 16 bits. That highest bit in an unsigned or an assigned, if it's a 1, that means the whole number is negative. And there's a slightly other conversion you do to it too, but that matters. In unsigned, it doesn't matter. That just means it's a bigger number. It's bigger than 32,767. If I'm combining an unsigned and assigned, what do I do with type conversion? By default, so here we type convert up from, we type convert up from integer to decimal or to float, right? We type convert up from integer to unsigned int without complaining. So if I had negative 123, this suddenly becomes, in the 16-bit things, a positive 65,000 something without complaint. And that has caused so many perversion problems. And that's why certain languages like Python and Java don't believe in unsigned numbers, because they say there's no such thing as an unsigned number and programmers can't handle it. But if I want to compare and I write code and I say, oh, let's compare a size of something, right? And I compare it to a result. So is it equal to some result or less than some result, right? Maybe let's do less. Well, some programmers put in, hey, if I have a bad result, I'm going to give it a -1. Well, size is unsigned. That -1 suddenly becomes something 65,535. And size is definitely less than that, so I win. And then I overflow things because it's thinking it's 65,535 in size. Instead of -1 saying there was a mistake. We see this all the time in programming. Okay, these type of errors. And so what we want to do is make sure everything is in the right range. The values make sense, the types make sense. We've checked for these and we code successfully. You know, are things too long or too short just by mistake or by these type errors? And is the format correctly? Date, phone number, social security number, are they in the right format? So I think that was it for that one. Yeah, so I'm going to stop there. I'm going to come back next time. But just think about these things.